Today we'll get started programming in Unity. I did a poll asking what language you guys would like to see, and the results were, well, conclusive. So today we'll be creating our first script. We'll have a look at how you can change properties and even add forces to an object. So I'm really excited. Let's just jump right into it. So whenever we want to program in Unity, we create what is called a script. To do this, we click on the object that we wanted to sit on, in our case the player, and we hit Add Component. Then we go down here, select New Script, and we can give a name to our script. In our case, it's going to be something like player movement, but you can really choose anything you'd like. And we select the language. In our case, that's going to be C#. So create an add, and you can see that Unity adds a new component. And that's because scripts in Unity are pretty much just custom components that we get to tell what to do. It's also created a script file down here in the project panel, and that means that we can add it to other objects as well. So if we now select our ground, we can drag our player movement onto that in order to make it affect the ground as well. But we don't want to do that, so let's just right click on it and hit remove component. So if we go back to our player and double click on our player movement script, it's going to open up in your script editor. If you're on Windows, that's either going to be Visual Studio, which is what I'm using, or MonoDevelop, which is also what you're going to be using on the Mac. It's really up to personal preference, and you're going to be able to follow along just fine with either. So this is what a script looks like just when we create it. There's a lot of scary stuff going on here. The thing about learning to program is that at first, you're just going to have to ignore most of the stuff that's going on. To clean it up a little bit, we can go ahead and delete the two using tags up here. And really the only thing that you should focus on right now is these two functions, where it says void start and void update. And these are created by Unity automatically. So let's have a look at the start function up here. The neat thing about the start function is that it will run when your game starts. That means that whatever code you put between this curly bracket and this curly bracket, so that means in here, is going to be executed when you start the game. Do note that in C#, it doesn't matter how many spaces you have. You can really space it out any way you want. You can even put it on separate lines as long as you don't split up a word like this. Let's just try and see if this is working by displaying a message to ourselves. To do that, we write debug.log and make sure to have capital letters the same places that I do, because C# is cap sensitive. Then we open up a parentheses and you can see that it automatically closes one as well. Then in quotation marks, we get to write a message. In our case, we'll just write something like hello world. Make sure you end this line with a semicolon. You're going to be doing that a lot. Whenever you write a command, you're going to end it with a semicolon. If we now save this by hitting Control S, you can see that it saves up here. Head back into Unity and hit play. Nothing is really going to happen in our game view. However, if we go ahead and look at the console here, you can see that it now says hello world. If you don't already have the console open, you can go window and then console. So the console here is used by us to debug our code. It allows us to write messages by using debug.log followed by our message, and it also displays warnings and errors about the code that we write. So we really have a love-hate relationship to the console. If something isn't working in your game, make sure to check the console and see if there's any errors or warnings. They might help you troubleshoot the problem. Alright, so writing hello world in the console is a bit boring. Let's have a look at what else we can do. Well, in fact, we can do pretty much anything in Unity. We can modify values, we can add forces to objects, we can add explosions, create game timers and menus. The possibilities are pretty much endless. And that's also kind of what makes programming scary, is that you have a lot of functionality available to you. But let's try and focus on a specific problem. So let's say that we want to go into our rigid body and disable gravity for that object. To do that, we need first of all to reference this rigid body component, and Unity makes that really easy. If we go into our script and go above our functions on this empty space here, create some new lines, and then write public, then the name of our component is called rigid body, then the name of the component that we want to modify, in our case rigid body, and now we need to give this reference a name that we'll use internally, so we can call it something like RB for rigid body. If we save that and hit back into Unity, we should now see an empty slot here with the name of RB. We can then take our rigid body and drag it into that slot. So now whenever we write RB in our script, it's going to refer to this particular rigid body. That means that if we go back into Visual Studio and instead of writing debug.log here, write something like rb.useGravity, we can set that equal to either true or false. In our case, we're going to set it to false, and then of course end with a semicolon. So save Save that, let's hit Inner Unity, and let's see if this value isn't going to change when we hit play. So let's hit play, and indeed the used gravity changes to false. We can see that our cube here is hovering in the air, and if we were to duplicate him so that the two would collide, you can see just how cool of an effect that already gives us. But this is just editing a tiny little property. We can also make our rigid body do different things. If we quit playing, go back into Visual Studio, we can actually add a force to that rigid body. So instead of writing rb.useGravity, let's write rb.addForce. And again, we open a parentheses, close a parentheses, and then end with a semicolon. However, you can currently see that this is displaying red. And the reason why is that we need to specify a few things. These are called function arguments. The addForce method wants to know how much force it should add in the different directions. So we could start with 0 on the x-axis, we could do something like 200 on the y, and maybe 500 on the z. Notice how I separate each number with a comma. We can then hit save, go back into Unity, and when we now play, we should see a force being applied to this object. Awesome. So let's stop playing, head back into Visual Studio, and what we want to do is not only add a force in the beginning of the game, we want to add a constant force in order to move our object forward. To do that, we can't use the start method. Remember, this is only called once right when we start the game. However, our update function is called once per frame. That means that whenever the computer draws a new image, and it does this multiple times a second, this function is going to run. So let's again put this on a new line to make things a bit easier to see, and we can then write rb.addForce, just like we did up here. We can input 0 on the x, 0 on the y, and let's try 200 on the z. Again, remember to close it with a semicolon. Let's also take our entire start function up here and remove it. So now we hit save, go back into Unity, hit play, and we should see our cube just launching into the distance. And indeed we do. However, even though our game currently runs just fine and we get no errors in the console, we do actually have an error in our code. If we stop playing, head back into Visual Studio, we can see that everything looks just fine. But there's one problem. And that is, if this method is called once per frame, and we add a fixed amount of force each frame, how much force we add over a second is actually going to totally depend on our frame rate. And that means if you have a really good computer that is drawing a bunch of frames a second, the cube is going to travel faster than on a slower computer that doesn't run as many frames per second. And the frame rate can even vary on the same computer. If a bunch of stuff is going on the screen, the computer usually slows down a bit in order to handle everything. Or if something is happening in the background, that might also change your frame rate. So in order to even out these differences, what we do is we multiply this value, the 200 here, with what is called time.delta-time. This is a bit confusing, but basically what time.delta-time is the amount of seconds since the computer drew the last frame. So if the update is running 10 times per second, this value is going to be 0.1. And if it's running 20 times a second, this value is going to be 0.05. So the higher the frame rate, the lower this value is going to get. And therefore it's going to even out the advantage that you would get if you were running on a good computer. If you don't get this right away, that's totally understandable. I sure didn't the first time, just right after me for now. So if we now save this and go back into Unity, we should actually see a pretty big difference. And that is, our cube is not moving now at all. And that's because on my system, it's drawing a lot of frames, and so overall the value gets a lot smaller than it was before. The workaround for this is super simple. We just need to go into our script and make this value bigger. I'm just gonna add another 0. Save that, go into Unity, hit play, and we should see him just storming off here. It doesn't look like much of a difference, but now we can at least know that it looks the same way on all systems. The final thing we're going to do is yet another one of those, it doesn't look like it's wrong, but it's actually a little wrong kind of things. And that is that Unity really likes it if we use what is called fixed update instead of update for calculating physics. And in our case, we are using the Unity physics system. So just make sure that whenever you do physics stuff, if you're adding forces or changing velocity, do it inside of the fixed update. Unity likes that a lot better, and it's going to make everything look a lot smoother when you collide with stuff. Also, if you find all of this confusing, I totally get it. One thing that you can do is use the fact that we can make comments inside of our code. So you can see this line here is grayed out. That's because it's marked with these 2 slashes. Whenever you create 2 slashes and follow it up with some text, that text is not going to be included in your code. And so it allows you to say stuff like this. So just go through your code and add some comments to help you out. You can even add comments at the end of a line. Also, I see a lot of beginners using spaces to indent their code. I find it a lot easier to just use tab, but it's something programmers have argued about for decades. So let's just save our code a final time and enjoy the result. Until the next video, you can of course play around with this by adding more objects into the game. Let's add another cube here, for example. And this already has a box collider, so it should actually collide. That's pretty much it for this video. I hope you liked it. If you did, make sure to subscribe so you don't miss out on future episodes. I upload on Sundays and Wednesdays. Also, if you're a fan of the series, you can always support me over at Patreon. Patreon allows you to donate a